All right, and we're live. So first, I know I've had a handful of you guys emailing me if you had submitted late work. That late work hasn't been updated in a while. I do plan on looking at that over the next couple days. I've been focusing this weekend more on the AP students since they're taking their exams today and tomorrow. Um, that should free me up to do another pass over grades, if not tonight, then tomorrow night, depending on how many questions I get from the people taking their exams tonight. So for today, I'm going to be going back through permutations and combinations. We'll take a look at some of the problems that we did on the test back in quarter one, and then take a handful for homework. So back when we first introduced this, permutations and combinations are both ways of getting a number of arrangements for possible outcomes. So for instance, if you have a situation where order is important, then you can repeat your options. So for instance, a telephone number. A telephone number typically has 7 digits in the US. Each one of those telephone digit numbers has 10 different options, 0 through 9. So if I wanted to know how many digits are possible in the United States, well, I've got 10 for digit 1 and 10 for digit 2, which is multiplication, and 10 for digit 3 and 10 for digit 4 and 10 for digit 5 and 10 for digit 6 and 10 for digit 7, which is 10 times 10 times 10 times 10 times 10 times 10 times 10, or 10 to the 7th power, where n is the number of options, and r is how many you pick. There are 10 options per digit, and we are picking 7 digits. Okay, any questions? Permutations with repetition first. Okay, for permutation without repetition, we stole an example from mathisfun.com last time, I think, where we had a cannonball, or massive cannon, rather. Where we were firing all of the balls in a pool set. So there are 15 balls in a pool set plus 1 white cue ball that doesn't count as part of this set. So I'm going to say there's 16 balls total that we are all going to stuff inside this cannon, and we will fire them out of the cannon, and then see which ball would hit closest, second closest, and third closest to the cannon. So if we did, first on my order is Aileen. How many options would I have for the closest ball to the cannon? Okay, we would have 16 options for the one closest to the cannon. What about the one that's second closest? Okay, and third closest? 14, perfect. So what we're really doing here is the chance of getting one permutation, so that's ball 4, then 3, then 15, would be there's 16 options for ball 1 and 15 options for ball 2 and 14 options for ball 3. That and statement tells you this is multiplication, so this should be 16 times 15 times 14 number of different permutations, number of arrangements that could happen for your first closest, second closest, and third closest ball to the cannon. If I want to set up a formula for this, we can use factorials because they multiply numbers that are always 1 less than what we had. But if you just do 16 factorial, you would count all the way down to 0. Running before my screen again. So 16 factorial would go all the way down to 0. If instead I wanted something like this, 16 times 15 times 14. Then I could cut this by taking out an n minus r, which is, if I'm going to pull 3 of these balls that are closest to the cannon, that would be 16 minus 3 factorial, which is 13 factorial. Okay, so this would be our 13 factorials will cancel, and that leaves us with 16 times 15 times 14, which is what this formula does. In your calculators, you have a shortcut that you can do for this, which is a permutation without repetition, or NPR. Again, n is your number of options, and r is how many you pick. Okay, I'm not going to worry about combination with repetition for your final exam. If you do want to take a look at some of the examples that we did later on when you're in college, we've got a whole PowerPoint on how to do combinations with repetition. But for the exam, I'm going to focus on combinations without repetition for your combination forms. So a little bit more useful for the poker probabilities that we'll be doing this for, which is very close to the formula that we had for a permutation where the order was important. But if the order is not important, then we actually end up with more options, and I'm going to show you why really quick. So let's say I have options A. Try to fix my pen really quick. See if that worked. I have options A, B, and C that we can put into any arrangement that we want. So if I did, I could have A, B, C, A, C, B, B, A, C, B, and C, A, C, A, B, or C, B, A. Okay, I think I've lost my pen for good. All right, so these are all of my options if the order matters. So as a permutation, we've got 6 options. If my order doesn't matter though, then as long as we get these same 3 options, A, B, and C, then we end up with the same combination. So all 6 of these are really one combination of A, B, and C if the order doesn't matter. So where we had 6 options of the permutation, we now only have 1 option for a combination. Okay, so if I did this with our combination formula, this would be 16 factorial over, we picked 3, I'm doing our cannonball example. Let me do our letter example first. Then I'll go back and do the cannonballs. Okay, so this is with our letter example. We have 3 options for letters, 3 factorial. And I'm picking 3 of those letters. This would be 3 factorial and 3 minus 3 factorial. Gives me 3 factorial over 3 factorial, 1 factorial. My 3 factorial is a cancel, 1 factorial is 1. So this is 1 over 1 option. Is only 1 option for combinations if the order does not matter. Okay, for our pull set example, we have 16 options for the number of balls that could land first closest, second closest, or third closest. But if the order doesn't matter, then ball 4, then 3, then 10 is the same as ball 10, then 4, then 3, because I'm getting the same set of 3 balls. So as a combination, I pulled 3 balls total. So that's N is 16 and R is 3. Gives us 16 times 15 times 14 times 13 factorial over 3 times 2 times 1 is 3 factorial times 13 factorial, which will cancel with what I had on top. Okay, 3 goes into the 15 5 times, and the 2 goes into the 14 7 times, so I'm left with 16 times 5 times 7 different combinations of balls from a pool set, which is less than 16 times 15 times 14. Any questions on permutations or combinations, just what it means? Okay. So let's throw up a couple more examples here. We're going to do some poker probabilities. I gotta pull up the cheat sheet for poker because I don't actually remember what our options for poker are. Okay, so I've got one pair. One pair in poker means that we could have any values that you want. So this would be something like value z, z, y, x, w. A value is something like, let's pull up a poker cheat sheet really quick. Actually, I think I've got one in another document over here. Hopefully. Nope. Well, that's working. So each card would have 2 options on the card. So if I have an ace of hearts, my ace would be the value. My heart is the suit. Okay, so each one of these is an option for value. So this could be ace, ace, king, queen, jack, for instance. I'm going to jump over to Jana. Jana, for a normal 52 card deck, how can I set up some combinations to give me a probability for getting one pair in poker? So pull up these standard poker decks. All right. So I want one pair. An example would be ace, ace, king, queen, jack. So I'm drawing 5 cards, and I want Z, Z, Y, X, W for my result. What should go on bottom first? 52C5, perfect. So there's 52 options for cards, and I'm picking 5 of them. Okay, and then if I go up to the top, let's do our ZZ first. So how many options for values of the cards do I have? I've got 4 options for suits. How many options do I have for values? A value is like 2, 3, 4, 5, 6. 13? Okay, so I've got 13 options for values, and I'm picking one of them to be the card that we picked 2 of. So that's 13C1. And then within that value, so let's say you pick aces, how many cards do I have total in the deck? So how many aces are there total? 4. So I've got 4 cards of every value. And then how many do you want to put in your hand? 2. Okay. Then for my next set, how many values do we have left in the deck? 11. Not 11. Not 2. We had 13 values initially, and you picked one of them, and then put 2 cards of that value into your hand. So how many values do we have left? 12 options for values left. Now, for this second part, I want to pick 1 card of the 4 for every one of these values. So how many of the values am I picking 1 card for? Not just 1. I want to know how many of the 12 values left do I want to take 1 card out of the deck and put into my hand for? 3. So there are 12 values left. I'm going to take 3 of them, and then for each of those values, how many cards of each of those values are still in the deck? For each of them. So we're looking at the king, queen, and jack now, for example. This is Y, X, and W. How many kings are still in the deck? 4. Okay, and how many do you want in your hand? 1. Okay, so let me see if I can write over this, and we'll explain what we just did. So this is... First we looked at values. Then we looked at how many cards of that value that we wanted. Okay, then we looked at values again, and we looked at how many cards we were pulling for those values. Okay, the reason why the 12 is C3 instead of just 12C1, 4C1, 11C1, 4C1, and 10C1, 4C1 is because it doesn't matter what order you pick these cards in. Since I'm taking 1 card out of 4 for both for all of the king, queen, and jack, it doesn't matter if you take kings first or second or third. Any questions on our 1 pair example? Okay, I'm going to try another. So let's do 2 pairs then. So 2 pairs would be something like ZZ, YY, X. So for example, ace, ace, king, queen, jack. Okay, next up is Kelly. Kelly, how would I do this? Okay, we're really close, except there are two values that I'm taking two cards of. So I can't make those separate. So this should be 13C what? 13C2, that's it? Okay, then what? 4C2. Okay, so I'm picking two values and we don't care what order out of the 13 values that are available. And then within those values, let's say I pick ace and king. Both ace and kings have four cards that are in the deck. I'm taking two cards of the four options for aces and two cards of the four options for kings and putting them into my hand. Okay, what comes next? Perfect. There are 11 options for values left that we haven't used. I'm going to pick one of them, and then within that one option, I'm going to take one of those four cards within that option. So if we picked aces and kings, then I've got 11 options left, everything that's not an ace or a king. I'm going to take one of those, jacks, and then put one of the four jacks into my hand. Okay, what should go on bottom? Perfect. Okay, cheating and going back to my poker cheat sheet. Okay, we've got one pair, two pair, three of a kind. Three of a kind looks like ZZZYX. So for example, ace, 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 king, queen. Over to Sarah next. So Sarah, how can we set this up? Okay. 13C2, so I'm picking two values, and then within those two values, how many of the four cards do you want to pick? If I do that, then I'll have six cards total, because you pick two values. That would be like ace and king, pick three of four cards. So you've picked two values, let's say aces and kings. Within the four cards for aces and the four cards for kings, how many do you want to pick? If I pick two, you'll end up with four cards total. So that would be two aces that you picked and two kings that you picked. Okay, I can start over if you want to go from left to right and do with your Z's. I'm going to go ahead and start over, I think. So I think this is how you are processing this, maybe. So if you picked two values, then you would have had to start with your y and x. If you want to start with your z's instead, then how many values are you picking three cards for? One. Okay, so there's only one value that we want three cards out of the four options for. So let's say we pick aces first. I want three out of the four aces to go into my hand. Okay, how many options do I have left for values? We've only picked one value so far out of 13, so how many options are left? Okay, I've got 12 options left now. And this time I want to take one card from two values. So there are two values that I want to do this for. For each value, king and queen, what should go next? For C1, perfect. So there are two values out of the 12 remaining that I want to take one of the four cards and put into my hand. What should go on bottom? 52 C5, perfect. Do you understand how we built it? Okay, cool. So recapping, we had one value of 13 that we picked three of the four cards within that value for. So let's say aces, we picked three of the four aces and put into our hand. Okay, there's 12 values left, everything that's not an ace. I picked two of those 12 values and pulled one of the four cards within that value to put into my hand, giving us three of a kind. Okay, I believe that brings us back to the top of the order. So this is Aileen next. Aileen, I'm going to skip ahead a bit and we'll do full house. A full house means we've got ZZXX for our order. So for example, ace, 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 king, king. How should we write this? (13C1) 4C3, okay. Okay. Perfect. Over. Awesome. Okay. I've gone through everybody. Almost. Jana, I'm going to set you on four of a kind. So four of a kind is ZZZZX. For example, ace, 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 king. Jenna, how can I do this? Okay, over. Awesome. Okay, last one. Kelly, a royal flush is the best hand in poker. Let me do royal. American spelling. Okay, royal flush is an ace, king, queen, jack, 10 of any suit that you want. Okay, what do you think the probability would be? Okay, 4C1. Sorry, go for it. So you've got 4C1, so you're picking one of any four suits that you want. Let me give you an example. So, example, um, excuse me. So we've got, ooh, that's big. Ace of Hearts, King of Hearts, Queen of Hearts, Jack of Hearts, Ten of Hearts. They all have to be the same suit, and they have to be Ace, King, Queen, Jack. Okay, so with that in mind, how many options for values do you have that are Ace, Kings, Queens, Jacks, or Tens? Okay, so my problem with that is, if you do 13C5, that means we could have picked any 5 values out of 13, so we wouldn't have to pick Ace, King, Queen, Jack, or 10. 13C5 means you could have picked 2, 3, 4, 5, 6. So how many options did we really have here? Okay, we can do that. 5C5, yeah. 5C5, we have 5 options for values that are okay for a royal flush, and I'm picking all 5 of them. If you wanted to look at it on a card by card basis, I have one card must be one of the aces, one card must be one of the kings, one card must be one of the kings, one card must be one of the jacks, and one card must be one of the tens. So I've got 4 options for suits, and then within that suit, let's say we pick hearts first. I must pick the one ace of hearts, I must pick the one king of hearts, I must pick the one queen of hearts, I must pick the one jack of hearts, and I must pick the one 10 of hearts. Okay, over how many options do I have for picking 5 cards total? 52C5, perfect. Okay, any questions on what we did here? Okay, I'm going to throw a curveball then. Okay, a Pinnacle Deck, which I did not spell correctly. A Pinnacle Deck is typically sold as a deck of 48 cards, which looks like this. Okay, but just like this. So, Pinnacle Deck is a 48 card deck where you've got 3 of every card, but you only have jacks, queens, kings, and aces. Okay, if we had a Pinnacle Deck, then I want to know, what is the probability that you would get ZZZ. So 4 Z's, XX, YY, WV. I did that in the wrong order, didn't I? Don't know my alphabet, apparently. Okay, so we've got a 10 card hand with this setup. Okay, we just did... I'm going to go back to the top of the order. Let's do Aileen first. Okay, for our Pinnacle deck, how can I get this probability? Ooh, wait. Sorry. This actually isn't possible with Pinnacle. I've got too many options. Let's do this instead. We'll do an 8 card hand. Okay, go for it. So you said 4C1. Okay, so you picked one of the 4 values, let's say jacks. How many jacks total do you have in the deck? Okay, we've got 12 jacks total. 12C4, cool. How many options for values are left? 3. How many do you want? 2, because I'm doing the same thing to both of them. What am I doing to both of them? Perfect. I'm pulling 2 of the 12 cards out of both of those 2 values that are remaining, out of the 3 values we have not used. Okay, so for instance, this could be Jack, 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 Queen, Queen, King, King, for an 8 card hand. What should go on bottom this time? 48. See what? 8, because we pulled 8 cards total. Okay. Appreciate that. That was a little bit hard to follow with me bouncing around and changing the problem on you, but thank you. We jump over to Sarah, and we'll do one more. So this time I want... Oop. Y. WWW X. All right. Still not following my order, but that's right. So Sarah, if I want a hand that looks like this, with 4 of a kind, 2 sets of 3 of a kind, and 1 other card. So for example, Jack, 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 King, 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 Queen, 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 Ace. What's the probability that I could get this type of hand from a Pinnacle deck? Okay, I've got 4C1. So we picked one value to be our first one that we're going to pick 4 cards from. Okay, there are 12 options and cards in that. And how many am I picking? 4, perfect. Okay, how many values are left? And how many of those values are going to do? Three C 2, perfect. Because I've got 2 values that I want to pick 3 cards for. How many cards are in each value? 12, and you're picking 3 of them to go to your hand. So that's 2 values. You'll pick 3 of their 12 cards to go into your hand. Okay, and last part. Not 2. How many values are left? 1. Okay. And then in that 1 value, what do we have left? $12C1. Perfect. Okay, there are 48 cards in the Pinnacle Deck. How many cards total did we pick out? Um, 11. There we go. All right. Any questions on what we did for our poker probabilities? Okay, I'm going to throw this to the chat. For today. Okay, so for the homework this time around, I have a retest that was given in Q1, so that means almost everyone hasn't seen it, on probability. And I'd like us to get through the first 3 pages of this up to single variable statistics. So you don't have to do the single variable statistics part, but I do want you to do the first 2 pages through the second half of the 3rd page. That's binomials and geometrics, both sections, and the permutations, combinations, and basic probability set from page 1. So I'll send to you guys now. Okay, here's your study guide, everything you need to know. I might edit that just so I don't have crazy capitalization on that, and send that to you guys in a second. All right, any questions on anything from today? Oh. Okay, for those of you who are taking an AP exam, I'm going to really quickly forward this as well. This is the schedule in Chinese time up here in red. I've just written on top of here. So if you had an AP exam, for instance, today is physics. Mechanical physics at 9 a.m. Pacific time is really 11:30 p.m. our time. So that means your test would be starting at 11:30. For all of these exams in the middle, your test is starting at 1:30 a.m. our time. And for all of these exams on the right, your test will be starting at 3:30 in the morning on the next day. So if it says Tuesday, you're actually starting 3:30 on Wednesday. Okay. If you have any questions about AP exam scheduling, you can stay. If you've got questions about anything else, feel free to stay too. If not, then I will see you guys in 2 days. Bye.